Okay, so we're going to be moving on to the 30th problem in the Grind 75. Yay, new decade. All right. This one is called Threesome, and we're given 30 minutes for it, so we're going to start the countdown now. Okay, so given an integer array nums, return all the triplets nums I, nums j, num k, such that I does not equal j, I does not equal k, and j does not equal k. And the sum of them is equal to 0. Notice that the solution set must not contain duplicate triplets. Okay, so let's see. So we can have sets that use the same number, as in this example. It's just the set itself must be unique and it must sum up to 0. Let's see, nums 0, 1, 1, nums 0, 0, 0. So nums.length will always have at least 3 values. And let's see. Is it always true that there will be a sum? No, it's not. Not necessarily. We would just return an empty list. Okay, so let's see. Let's just think about how to actually do this. I'm not going to worry about coming up with the most optimal solution right off the bat. So again, we're going to need 3 separate numbers at 3 separate indices. The elements themselves can be the same. It's just need to make sure we're looking at 3 different indices. So how do we, if we were to get, every possible combination of 3 unique indices in a list, how would we do that? We're also assuming that the sets -1, 0, 1, in this set right here, would be the same as, say, 0, 1, -1, or 1, 0, -1. Order does not matter, though. Yeah, we just want unique sets like that. So, how do we... So if we did, like, say we had I here, J here, and K here. Let's see. So you could move K through all of them. And then move J up and then go through all of them. So we could have 2 values that are fixed, like say I and J, and then we move K through everything. Maybe I and 1, move through it everything, and 2, move through everything. Is that right? I wonder. Well, I'm not going to worry about all the possible combinations right now. I'm going to think back to what we did for twosome, actually. And remember how we added a value to our hash set? So first off we had a hash set, and the key was the element, so element value, and the value part of the key value pair was the index in the list. So let's see. So once we get one value, like say we have -1, then we have two values, then we can basically apply two-sum on the rest of the values, and they have to sum up to the absolute, or I guess like the inverse of our original value. So we can try that. Then, okay, I believe that would still be, that seems to be O(n) squared to me, because the way I'm thinking of it is we start on this value and then iterate through everything else, and start on this value, iterate through everything after it, because we had already checked -1. Can we do the same for that? For 1, because yes, we've already checked for, okay, I believe that should be okay. Let's see. So we're going to try that first off. I believe it's O(n) squared. And we're going to see afterwards if there's any way to optimize. So to get down into the implementation, we're going to have something of this static type that's going to be called result. It's going to be equal to a new version of this, but we're going to use a concrete class, not the interface. And we're going to say array list of array lists that contain integers. Okay, so that's good. And we're going to have our outer for loop that's just going to be I initialized to 0, and while I is less than nums.length. Yes, just a regular for loop. The inner one's going to be slightly different because we are not going to check for values before I. So we're going to say int j is actually equal to I. And we're going to say while j is less than nums.length. Nums, right, yes. We are going to just increment it normally. And then we're going to apply toSum to it. So what I'm going to do is create a hash map of integers and integers. This one is going to be called, what is it? I guess we'll call it match. And this will go here and like so. And then int I is going to start out here. So yeah, we're going to have j. And so again, we have three sum. Will we have found every combination by the time we set I equal to this value right here? Because if our I is this, then we can only do toSum on these two values right here. Again, we don't want to have any values from repeating indices. I guess because we're doing brute force, I'm not going to do anything fancy. Basically, we're just going to skip over I. So we're only really going to apply this if j does not equal I. And we're going to perform toSum again. So if j does not equal I, then we have an existing value I, right? Say it's -1. And we want to find, that will essentially be our target, I guess. Yeah, that will be our target. And we will want to add up to that target. Or what do we want to do? We want to add up to the negative of that target. Right, so if I is target, okay, then what are we going to do with j? So we need to check if there is a value in our hash map. I don't really like this doubly nested if statement, but we're going to roll with it for now. If match.contains some value that is equal to I plus j the inverse of it, I guess. So let's look at this one. So we know this is a pair, right? So say our I is this, and then our j gets here. We're going to be looking for a value that is the same as that, or wait. So we know one possible combination could be, say, -3, 4, and -1. So say we do 4, -3, and -1. So 4 is I, -3 is j, and then -1 would be k eventually. Let me think about this for a little bit. So we would want our target to be the inverse of those values, right? So we get two values and their sum. So 4 and -3 would become -1, right? And then that means we need a target of 1 to balance that out and give us 0. So basically what we want is I plus j times -1, right? And does that hold up for this? So if we have -1 and 2, we have -1 and 2, that gives us 1. Then our target value will be -1. Yeah, so that should work. So if match.contains, what is it? I plus j times -1, then we'll want to throw ij and the matches value into our list, right? So that means we will create first an array list. So array list will contain integers, will be called triplet, will be equal to not entirely sure if we can do it this way. I'm just going to do it this way, triplet dot add I, triplet dot add j, and then triplet dot add match dot get I plus j times I plus j times -1. Right. Because again, we are storing the element first, and then its value is the index. Okay? So if there is not a match, then what we want to do is add that value to our match hash map, right? So match dot add, for maps it's actually put. Yeah, that's right. We're going to put j, and then we're going to do nums j. So actually no, it should be the other way. It should be nums j here, and then j here. Okay. As long as those. And then once we exit out of this for loop, we also want to clear, oh wow. We want to clear our match hash map. Well, we don't really need to actually, because they all have the appropriate values in them already. It's not really a need to do that, seems like. And we're going to say, why does it keep doing that? I don't really know. I mean, if this functions properly, we should just be, oh, where are we? I think we might need another, yeah. Spacing got off. So here we would want to, inside of that double for loop, we're going to want to return match. Okay, and I'm going to go through this implementation, make sure it actually holds up. I'm almost certain that this is not the most efficient way to do it, but I want to make sure that this works at least. So, okay, we're going to start off with -1. That's going to be our anchor. And then we're also just going to start out there. And we're only going to look if j and I are not the same. So then we're going to do nothing, and we're going to go over to here. And we're going to say if match.contains a value -1 plus 0 times -1, which turns out to be this +1, if it contains that, then we're going to create our array list, add just the appropriate indices, or not the appropriate indices. We want to add the actual values from nums. And then we're going to add that matching value. Or no, so that would be its index, right? And also we have to do contains key. I believe we can just do get key as well. Okay, so then that will be added successfully. However, it will most likely have duplicates too. So how do we prevent duplicates? Else match.put nums. Yeah. So we have this check here to make sure I and j do not equal each other. But that third value could end up being something we've already put in, so I mean, let's just think about this. Again, if we anchor -1 and then we do toSum on this list, how does that change things? We will get a triplet if this value is part of a triplet. And we move on to this one. If this value is not part of a triplet, then we will go through this entire thing and not add any to our array. But then, say we go into this one, that's tough too because there can be duplicate values too. So really we want to make sure we don't go over the same set of indices twice. So that's definitely sort of tough. With 3 pointers, the only possible triplet sums up to 0. What else can we do? is it sort of, I guess, dynamic programming in a sense? Choose someone that anchor this. That means we've gotten all triplets with this value, or I guess with the value at that index. So meaning we've gotten this and this. Then we move on to here, and then we apply 2 sum to everything. You know what we could do actually is have a hash set of hash sets. So we would do this typical, we would maintain this iteration. And we could still get the appropriate triplet. It's just that we would put it into a set, check to see if that set already exists, and if it does, then we simply won't add the set. I mean, we could add the set, but it wouldn't change anything at all. The only thing we would have to do is convert from, now why does it keep doing that? That's really bothering me. We're gonna have to convert from a hash set of hash sets to a list of lists, list of lists. So we could iterate through the sets for entry and sets and then do 2 array for each set. And then we could just do 2 array for the overarching. Or there might just be a 2 array list for collections. So I've come up with a conceptual solution, but this is probably not the most efficient. And because of that, I'll just stop the video right here.